Hi, in this video we carry on with the topic of surds, and this video will cover the ideas of simplification and multiplication and division of surds. And some of this you might already know, but you can hopefully pick up a few things. Our outcome that we desire is that by the time that you watch this video, you can say, hey, I can identify the highest square factor of any term to help simplify a surd, and I can handle multiplication and division of surds. You'll remember from previously that a surd is an irrational number. It's in the form of the root of something, where that something, here marked as n, is positive and it's not a perfect square. And so therefore the thing under is a rational number, but the surd itself is an irrational number. And each surd represents an exact unique value, but it's a number that never ends and never repeats. That's what makes it irrational. So this is a way of writing that irrational number exactly. Now think about if you had a square, and I told you it was 10 units squared for the area. Well, what would be the two sides of the square? They would have to be root of 10, because root of 10 times root of 10 would give me exactly 10 as the area. Or if you had a triangle and you knew one side is 1, one side is 2, if you were going to, with Pythagoras' theorem, figure out what is that third side, the hypotenuse, take 1 squared plus 2 squared should equal x squared. Well, 1 squared and 2 squared, that's 5, and then that equals x squared, so x equals the root of 5. And again, now you have the exact answer of what that is. So the thing under the root sign is called the radicand. And if that is a perfect square, then it's not a surd. So we remember that if you have something that works out perfectly, it's not considered a surd. If that thing is an algebraic thing and it works out perfectly, it's also not a surd. It could look more complicated, like AB, AB. Well, if there's two A's and there's two B's, then they could have been squared, so they could just equal AB. Therefore, it's not a surd. And this is because squaring and square rooting, these are inverse operations. So we know now what surds are. We want to think about, well, how do we get to the simplest form of a surd? And how do we find these square factors? Now, thinking ahead a little bit, we're going to see that when we multiply surds or divide surds, you can multiply surds and have a square root sign over xy, or you can express that as the square root of x times the square root of y. That's the same thing. So when you're dividing, also you could have the square root sign over both x over y, or you can have the square root of the thing on top over the square root of the thing on the bottom. So these two things are true, multiplying and dividing, and we have to remember that they will help us to simplify. Sometimes, not always, it's more efficient to simplify before multiplying and dividing, but we'll see as we carry on. Those same rules, if you look at them with numbers, you can look and see that if I had something like the root of 50, I'm allowed to break that down then into a perfect square plus a root, and that is considered simpler form. Or you can split up, if you had 16 over 2, you could split it up and do square root of 16 over the square root of 2, and those perfect squares there can simplify to regular numbers. So these principles help us to make simple forms of surds. So a surd in its simplest form is when that thing under the root sign, the radicand, is an integer and has no perfect square factors greater than 1. Now, for example, if you said the square root of 32, two factors of 32 are 16 times 2. So this, because it has a factor that is a perfect square, it would be considered to be not in simplest form. If you have a number like the square root of 21, you can still break that down into two parts, square root of 3 times 7, for example, but neither of these are perfect squares. And in fact, 21 doesn't have any factors that are perfect squares. So square root of 21 would be considered simplest form for a surd. So if it's not in simplest form, the idea is that that number, which is the perfect square, we take it out from under the root by writing it as two different roots, and that root 16 can be just 4, or you end up with a composite number there with a coefficient and the surd called 4 root 2. That number now would be simplest form of the root of 32. So you try a couple. Is the root of 24, is that simplest form? You can pause the video, or if you have an answer already, what do you think? Hopefully you said false, because 4 is a square factor of 24. So you could break it down to 4 times 6, and then you could simplify. 4 times 6 as roots, or the 4 would become a 2, so it would be 2 root 6 would be simplest form. What about if I had something like this? The root of ab cubed. Is that simplest form? Pause the video. What do you think? That's also false. Why? Because you could take a b squared out of this, and b squared is a square factor greater than 1. So what would that look like? You could say, well, this could be b squared times root ab, and the b squared could just become b, so it could be b root ab in simplest form. What about root 123? Is that simplest form? Pause the video and think about it. This one is actually in simplest form, because although it has few factors, 1, 3, 41, 123, there's no factors of it that are square numbers. And probably you had to use your calculator or something to figure that out for sure. So if we want to find the simplest form of a surd, we want to be able to find those highest square factors. So how do we do that? First of all, we look at it, and sometimes we can just see it. But you can also list down the factors, like factor pairs. So if we were going back to that example of 32, I could say, okay, 32 can be 1 times 32, 2 times 16, 4 times 8. So there's another square factor. There's 1, 4, and 16. Or if you took a different number and you said, okay, I have 72. So here there's more factors to think about. You could have 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, 8 times 9. And you notice there's a number of square factors, 1, 4, 9, 36. So 32, 72. Keep these numbers in mind as we go on to a couple future questions. When you simplify surds, you can actually simplify using any square factor. It'll just take you more steps. Kind of like simplifying a fraction. Sometimes you can divide it by one number and then realize, oh, it still divides by something else. But the most efficient way is to find out what's the highest square factor. So for 32, those factors are 1, 4, 16. So the highest square factor we said was 16. So you have 16 times 2, or 4 root 2 would be simplest form. Now, back to 72. True or false? The highest square factor of 72 is 9. Do you remember? That's false. Why? Because 36 is also a factor of 72, and it's higher than 9. Now, how does that make a difference? Well, Another way of finding square factors is to write the number as a product of all its prime to how many degrees of primes. So 72, if you had 2 times 2 times 2 times 3 times 3, you would get 72. So that's 72 as a product of its primes. And you can see that you can get a 2 squared out of that. You could take a 3 squared, that's your 9. Or you could take 2 squared times 3 squared, and that's your highest square factor. So if you express it as a product of its primes, especially with a big number, this is sometimes helpful. And then you can see what the biggest square factor is by looking at those prime factors. So if I go directly to using 36 as the highest square factor, you'll see that it saves steps. So you could use 9. Say you broke down root of 72 and you said, okay, it's root 9 times root 8, 3 root 8. Well, actually that's not simplest form, because root 8 could also break down with a perfect square factor. It could be 3 times 4 times 2, and that 4 changes to a 2, which those two coefficients then are multiplied together and you get 6 root 2. So it would be quicker to note that 72, the root of 72, could be root 36 times root 2, which then directly gets you to that 6 root 2. You come up with the same answer, you just use less steps. Okay, what goes in the blank here? Can you start to guess? What is the blank that we would want to fill in here? How do we get root 75? Okay, hopefully you would say 5. It needs to be 3 times 5 squared. 3 times 25, and that breaks down then to 5 root 3. Okay, here's 3 more. I want you to try. You can pause the video, and when you're ready, come back and see the answers. Okay, you ready? Hopefully for 45, you got 9 times 5, which makes 3 root 5. For root 28, 4 times 7 makes 2 root 7. For 98, 49 times 2 makes 7 root 2. So when you're looking for square factors, you're doing that because that way you can simplify a surd. And you can find that highest square factor either by spotting it, by listing factor pairs, or by writing the term as a product of its prime factors and then picking the highest square factor. So we've started to look at some that have a coefficient with them. So 3 root 2, that means 3 times root 2. So it's similar like working with algebra. It's almost like having 3a. And when you're simplifying, you need to multiply the surds together and the coefficients together and not multiply them with each other. That's basically what you need to keep straight when you're multiplying. So for example, here, you have 3 root 5 times 4 root 3. The 3 and the 4 multiply together to give you 12, and then the root 5 and root 3 multiply together to give you root 15. Here's 2 to try. The question goes, write 2 root 18 in its simplest form as some unknown called k root 2, where k is an integer. Okay, so pause the video and have a go and try it. See if you can come up with how I would write this as something root 2. Okay, welcome back. Hopefully you got that 18 can be 2 times 9. That then breaks down. The root 9 becomes a 3, and here then you multiply those coefficients and you get 6 root 2. Here's another one to try. Pause the video and have a go with this question. Okay, welcome back. Hopefully you got to see that 4 root 27 could be 4 times 3 times 3 times 3. And 2 of those 3's would become a regular 3. And then you would end up with 12 root 3. All right, if you have time, here's a bunch more that you can match the left-hand column with the right-hand column. Pause the video, have a look at it, and decide which surd would this surd on the left-hand side simplify to, and then what would be the other unknown that goes with it. You definitely want to pause the video for this one. Okay, welcome back. Hopefully, as you're looking at these options, okay, so here are some answers, and the working as to why is also shown on the screen. So hopefully you can match them to the ones that are here, and you can see the working if you have questions. And so this is the ones that match, and if you want to see that working, you can pause the video and have a look at it. How to simplify. We've already talked a bit about adding and subtracting surds in the last video. So we said that you can collect like terms of surds as long as you have the same thing under the root, which is called the radicand. Now, we added things like 2 root 2 plus 5 root 2 is 7 root 2. You can see now from simplifying that if you ended up with something that's different, there might be a chance that I could simplify and then be able to add or subtract. For example, here, root 50 could be root 25 times root 2, which is then 5 root 2, which then allows me to add them. So are these like surds? They're not right now, but could they be? Well, let's see. You could take the 12, break it down to 4 times 3, which is then root 4 times root 3, and suddenly, yes, you could add these two. They can have the same radicand and they can be like terms. What about root 12 and root 8? Well, they have a common factor, right? They have the common factor 4. So maybe I can break it down to root 4 times root 3, root 4 times root 2. And then the root 4's change into 2's. But, they're not the same because one is a root 3, the other is a root 2. So they're not like surds and you couldn't add or subtract them. So which ones could you make the same here? Minus 3 root 2 and root 8. Which ones could you make like surds here? Or which ones are like surds? Here you have algebra. You can pause the video if you want to. When you come back, I hope you find that these three could all be like surds. That a squared in the top right-hand side, that would actually come out of the radicand, and it would just be minus 2a root b. Now they could all be added and subtracted. So surds that have the same radicand are like surds. And because a surd represents a unique value, then these surds can be collected together just like you collect a's and b's in algebra. So here's an example. You could collect 3a, 4b, 6a, 7b, and you would end up collecting all the a's together and all the b's together. Well, that same thing, you could have 3 root 2, basically having your a be root 2 and your b be root 3, and you can see that you could just add them up. So you would collect all the things that are root 2 and get minus 3, and collect all the things that are root 3 and get 11 of them. Look at this question. Which one out of A, B, and C is the correct simplification, simplest form now, of what's listed here? You have to collect all the like terms together. You might want to pause the video and then compare your answers. Okay, welcome back. Hopefully you got C, which is the correct answer. Sometimes you have to simplify before you can collect like terms. Like this one, it says write root 45 plus root 20 in the form of something root 5. Well, neither of these are root 5, so I have to simplify. But both of them can simplify to something root 5. 45 is 3 root 5, root 20 is 2 root 5. Then I can add them together and get 5 root 5. Here's one for you to try. You can write it down in your notebook, pause the video, and have a go and try it. Okay, welcome back. Hopefully you could see that they can all switch into root 3. And then you can add and subtract them and end up with 5 root 3. So we're going to carry on now in this lesson and talk about multiplication and division of surds. And we need to cover what squaring a surd, how we multiply, how we divide, and what rules stay the same as we do this multiplication and division. First thing that we need to keep straight is that when you square a surd, what happens? Now, first of all, let's just try. There's 6 questions here, and you need to decide if they're true or false. Okay, so true or false, these statements that are here. Now be ready to defend your answers. You'll need to copy them down, or at least copy down 1, 2, 3, 4, 5, 6, and decide true or false. Okay, so pause the video. All right, ready to look at your answers? True or false? That first one is true. Second one, false. You can't subtract like that. They're not the same, right? Also false. You can't add surds if they're not the same. Root 4 times root 4, is that 16? No, it would be root 16. So it would be, the second one would be true. And is root 9 times root 9 equal to 3? No, it would be 3 times 3. When you multiply a surd by itself, like root 3 times root 3, you always end up getting that radicand, the thing that was under the root to begin with. If you would do something like root 11 and square that, that's like root 11 times root 11, and that just equals 11. So sometimes we multiply, then we have to simplify. So look at this question. If I have root 3 times root 6, what is simplest form? A, B, or C? Which one would you pick? Okay, did you come up with an answer? The right answer is 3 root 2. Some of you might have said that first one, but this answer isn't simplified. Try a couple more. What if we have root 8 times root 5? How could I multiply and then leave them in simplest form? You try it. Okay. Well, that's 8 times 5, so it's root 40. But in simplest form, that would be root 4 times root 10, so it's 2 root 10. How about this one? Root 8 times root 6. Try that one. Okay, welcome back. Hopefully you found that the root of 48 can also be root 16 times root 3, so it can be 4 root 3 in simplest form. When you're dividing, you can take root 8 divided by root 2 and just imagine that they're all under one root sign. So root 8 divided by 2, root 4, which just is 2. If you have something like root 40 divided by root 8, you can just divide those two numbers and get root 5. So in simplest form, here's one to try that has algebra in it. Again, try to remember those rules for multiplication and division. And what would you get if I took these two roots and multiplied them together? Have a go and try it and come back. Okay, hopefully you got an answer that looked like the root of 18 xy cubed. But both 18 can be broken down into root 9 times root 2, which 9 then becomes just the 3 outside. And y squared can be taken out, which becomes outside of the bradicand, it is just y. So you end up with 3y root 2xy. Try this one. Okay, come back. If I have 6 over 24, both are roots. That is like, I can write them under one root, so then I can just reduce to lowest form. And the square root of 1/4 is actually 1/2. So what do I do here when I have fractions and then I have multiplication? Well, I just multiply those fractions. I take 1/4 times 3/4 makes 3 over 16. Then I can break those two things apart. I can leave the root 3 on top, and I can take the root 16, and I can say, oh, well, that simplifies, and that can just be 4, a regular 4. So multiplying and dividing surds can be made easier if you simplify the surds first. If you have something like root 48 times root 27, simplify them first, then you multiply the coefficients, 4 times 3, and then you multiply the radicands together. You get 4 times 3, that makes 12. Root 3 times root 3 makes 3. So in this case, you end up with something that's not a surd as your final answer. Try this one. Of course, you can do it on your calculator, but hopefully you could also eventually find that 162 is 81 times 2. 81 becomes 9 root 2, and 8 can become 2 root 2. That one you'll run into so often that you probably will memorize it soon. And then I multiply the 9 times 2, and I multiply the 2 times root 2, which again gives me the same answer I got the last time. Here's 3 for you to try to simplify. You can pause the video, take some time, write them down, see if you can work out an answer, and then on the next couple slides you can see if your answers are correct, okay? So I would pause the video now. Welcome back. Okay, so here are some answers to those questions that you were working on. So if you are thinking about order of operations, you have to do the multiplication first. So you have to multiply. This one simplified, root 75, down to, well, what would it be? 3 times what? Oh, 3 times 25. So it becomes 5 root 3. Then that's multiplied, and I end up getting 15 root 15. Then that can be added together with 2 root 15, and you get 17 root 15. So hopefully you got an answer like that. B, you can see there, answer, final answer. If you have questions, you can discuss it. And C, you have some simplification to do, and then you have to remember that you have subtraction on top, you have multiplication on the bottom, and those operate differently. But you should end up getting root 2 over 20 as your final answer. So when you're multiplying and dividing, we remember that you can have them under the same root or you can have them separately. And sometimes it's more efficient to multiply or divide, to simplify before you multiply or divide. Okay, just a few more things we want to cover yet in this lesson. In multiplication with algebra, we learned that you can distribute a term into a bracket. And if you are expanding something with surds, you can distribute into the bracket the same way. But you have to remember that you multiply the coefficients together and you don't multiply the coefficient together with the surd. Like you don't multiply In this case, 3 times 5, you multiply the 3 times the 2, root 5, and the 3 times the root 27, and you end up getting 6 root 5, and then they've simplified the root 27, and you end up getting, instead of 3 root 27, you end up getting, pulling out a 9 and pulling out a root 9, which becomes a 3, 3 times 3, and then you get 9 root 3 as your final answer. Once you have two different surds in lowest form, you can't actually do anything more with them. This would be the final answer expanded. Here's one for you to try. Pause the video, multiply it, and see what you get. Okay? Hopefully you got a final answer of 12 root 3 plus 20 root 2. You can check your work with the work on the screen. If you're distributing a term outside the bracket that is a surd, then you have to multiply surd by surd, and the coefficients are still there. So for example, I multiply root 2 times 3 root 3, and I end up getting 3 root 6. Multiply root 2 times minus root 6, I get minus root 12. That can be simplified because I can take a perfect square out of 12, and I end up getting 3 root 6 minus 2 root 3. Try this one. Pause the video. Okay, welcome back. This is 6 minus 5 root 10 as final answer. All right, here's another one for you to try. Maybe that. See if you can find what is the simplest form of an answer in this case. Okay, did you come up with an answer? All right, the answer is 50. And how do you get to 50? If you didn't get there, you multiply coefficients, you multiply the surds together, and you distribute them. Okay? The working of it would look something like what's here on the screen. You can pause if you need to look at it. Here's one more. Distribute this term with the terms inside. This is practicing doing it with algebra. Okay, pause the video, try it. What did you pick? A, B, C, or D? Well, the correct answer is C. A and D might be versions of what you got, but they are not fully simplified. Okay, so the answer should be C. Here's one more for you to try. Expand and simplify. All right, if you've worked on an answer, these might be some of the steps you'd come through. And in the end, you end up with root 2s, root 6s, root 3s, and just a regular number. In your textbook, you get some practical questions, and these are some practical questions that are similar, where you're trying to use surds to calculate areas of shapes. So if you have time, I recommend that you would try these 3 questions that have to do with areas of shapes. If you try them, then pause the video, and then you can compare to the answers on the next couple slides. So this would be the answer for 1A, if you're there, 1B, and 1C. Now this one has a little bit of steps in it. First you have to find what is the length and width, and then you have to figure out, okay, well then how do I use that to figure out what the area of the thing is? Okay, so what have we learned? We've learned that you can multiply surds with surds and coefficients with coefficients. And when you have a bracket, basically you're doing the same things that you do in algebra. You're distributing the terms across the bracket, and if you had two or more binomial expressions, like it's like two brackets of algebra, you have to still follow the same rules and think I have to multiply. In this case, I have to multiply the first terms, and I multiply the outer terms and the inner terms and the last terms. I think you'll remember last year we talked about FOIL, first, outer, inner, last. Somehow you have to remember you get 4 terms out of a product of two brackets like this. So it's always important to simplify whenever possible. And that's all for this lesson. You basically should be able to do anything from 3.4 after this, although question number 8 in 3.4 actually has a concept that you need to know the next section. So I would skip number 8 if I was giving homework from 3.4 at this stage. All right, have a good day. Bye.